Welcome to Maths with EJD. In this video, I'll start talking about tests for convergence. So we're going to have like 4 tests, including, okay, I think it's important to mention those tests. Tests for convergence. Okay, that's what the next 4 videos we'll be talking about, starting from this one. So the first test is what we are looking at in this particular video. That's the nth term test for divergence. Okay, that's the one this video is about. The next test will be about the integral test, a whole video dedicated to that, the integral test. Then we'll also be looking at the comparison test, comparison test. And lastly, we'll look at ratio test. Okay, ratio test. So all these are tests for convergence. So I'll take them video by video. So in this particular video, the focus is on the nth-term test for divergence. And we're talking about the divergence of convergence of series. All right. In the previous video, I talked about infinite series, and we saw partial sums, we saw how to visualize them and things like that. So in this video, I'll be talking about tests for convergence with the first video, the nth-term test for divergence. So let's dive into that right away. So the nth-term test for divergence. Now, what's the concept of the nth-term test for divergence? What's the concept behind this? So, okay, let's just see the concept. The idea is that if the limit as n approaches infinity for a particular an in a sequence is not equal to 0, if the limit of that expression, if the limit of the sequence as n approaches infinity is not equal to 0, or the limit does not exist, or the limit does not exist, so we can say that the series of that sequence, the series an of that sequence, actually diverges. So if we have a series, this series, right, and we look at this an, and we find the limits of that an as n approaches infinity, and it is not equal to 0, or the limit does not exist. So if the limit exists, but it is not 0, it is different from 0, or the limit does not exist altogether, then it means that the series or that sequence actually converges. In case you've forgotten, a series is actually the sum of the terms of a sequence, and that is why sequence and series go together. So for the n-term test for divergence, this is the situation right here. So on the other hand, right, if the limit as n approaches infinity of that an is equal to 0, then we say that the test, then we say the test, then we say the test is inconclusive. The test is inconclusive. If we end up getting the limit to be 0, then we say that the test is inconclusive. Okay, so let's look at some examples, straight to the point. Examples. Okay, we are going to consider 2 examples. Imagine example 1. Example 1 is this: tests the series, test the series summation as n goes to 1 from 1 to infinity of n over n plus 1. So we want to test this series for convergence or divergence. Okay, so what we just do is okay, the solution now, you have summation from n equals 1 to infinity of n over n plus 1. So if you compare this with summation from n equals 1 to infinity of an, so it simply means that an is equal to n over n plus 1. Okay, that is our an, because what exactly we are looking for is we want to find the limit of an as n approaches infinity. So if you go on and say that the limit of an as n moves towards infinity is simply the same thing as the limit as n goes to infinity for n over n plus 1. Of course, usually the first thing you want to do is to substitute directly. That, I mean, if you check my calculus playlist, that's the kind of thing I said right there. So in that case, you have, if you substitute directly, you have infinity over infinity plus 1. That is infinity over infinity, and that is infinity. So, but I mean, if you have this, you cannot conclude yet. Don't conclude yet. Don't conclude yet. Find a way by which you can check this expression, you can do something about it. So let's check. So, but the first thing, the rule of the thumb is substitute infinity directly first. If that doesn't work, look at other things you can do. If you do every other thing you can do and you still get infinity or and all that, then you can conclude that the series will be divergence. So now we have as limit of as n goes to infinity for n over n plus 1. So another thing we can do is we can say limit as n goes to infinity. We divide each term by n. So we have n over n because n is the highest power here. All over n again plus 1 over n. Okay, so the limit as n approaches infinity is n over n is 1. All over n, 1 again plus 1 over n. So with this adjustment, you may have it better. So you cannot substitute infinity now. So you have 1 over 1 plus 1 over infinity. Now, remind yourself of something that anything any let's assume that you have any number x divided by 0, the result is infinity. So if you cross multiply, you have 0 times, you have x times 1 less x, 0 times infinity is 0 infinity. So what if you divide through by infinity? So x over infinity is 0 over infinity, 0 infinity divided by infinity. This cancels out, so your x over infinity is equal to 0. Now this is to show you that anything divided by infinity is 0. Okay, so that means that we can take this further and say that the limit as n approaches infinity for an, okay, for an is actually the same thing as 1 over 1 plus 1 over infinity now is 0. So we have 1 over 1, and that is equal to 1. So we can say, therefore, limit as n approaches infinity for an is equal to 1. Now, what does this say about convergence or otherwise? Okay. So this is saying that because the value is 1, so since since the limit, since the limit, of course, we see this limit is not equal to 0. Okay. Since the limit is not equal to 0, then then um then the series summation, the original series, right? Summation n equals 1, okay, to infinity of n over n plus 1, of n over n plus 1, that series actually diverges. So when does it converge? If it's less than 0, because we know 0 is inconclusive, right? So if it's less than 0, we say it's inconclusive. Okay. So that okay, yeah, that's one example. Let's see another one. Let's see another one. So now this diverges. Let's take example 2. Example 2. Example 2. So for example 2, the question is to test summation n equals 1 to infinity 1 over n. Now you see, don't forget the idea here is we're talking about the nth term test for divergence. Okay, divergence occurs if the limit is not equal to 0, and if it is 0, it is inconclusive. Then it means if you get something apart from all this, I mean it's either diverges or inconclusive, depending on based on this particular one. So next, let's see the limits. The limit. We want to test summation from n equals 1 to infinity of 1 over n. Okay, we want to test this. So how do we go? Again, if you write summation from n equals 1 to infinity of 1 over n, if you compare it with the general form, which is summation from n equals 1 to infinity of an, that tells you that an is equal to 1 over n. So now you need to find the limit of that 1 over n. So you say limit, okay, I guess I want to change course now. I want to change marker rather. So here I have limit as n approaches infinity for an, which is the same thing as limit as n goes to infinity for 1 over n. Okay. And by the rule of thumb, right, I said the first thing you do is substitute the infinity directly. So you have 1 over infinity. Interestingly, 1 over infinity is 0. Okay. So we say therefore limit as n tends to infinity for an is equal to 0. And what is the second condition about 0? Okay. It says that if limit of an as n goes to infinity is equal to 0, then the test is inconclusive because the test itself by essence is in essence is the nth-term test for divergence. So it's basically that we are testing for divergence. So it's either diverges or it's inconclusive for the nth-term test. Okay. So we can reach our conclusion now that since the limit as n goes to infinity for 1 over n is equal to 0, then the divergence test, okay, for the divergence test for summation from n equals 1 to infinity of 1 over n is inconclusive. It's inconclusive. Okay. So, and with this, we come to the end of this video. All right, we have come to the end of this video, and in the next video, I'll be talking about the integral test. So this first one is done. So next will be the integral test. So tune in. If you have not subscribed to this channel, you don't want to miss the next video for sure. So if you are sure you don't want to miss it, be sure to subscribe to the channel right away and hit the notification bell so you can always get alerted each time a new video is released. Then comment, let me know how helpful these videos are. Also, go ahead and you know let me know if you want to teach a topic or solve a problem. Of course, like and share also so that more people can have access to this great content. Till I come your way again, keep doing yourself well. Bye.